In this example, we're trying to take 1 minus the sine of theta and divide it by 1 plus the sine of theta and show that that's going to equal the secant of theta minus the tangent of theta squared. So, like in the last example, I'm going to want to try to turn everything into terms of sine and cosine, because that's going to that's the kind of the smallest pieces that we can make. Everything can be converted back towards those, and this is going to make things a little more difficult for me overall if I don't do that. But also, I have something over here that's very common. You'll see these kind of parts: 1 plus this, 1 minus this. This kind of sets itself up very well to be converted to other things, because we can use that tool of the difference of squares. So when we do the difference of squares, a squared minus b squared is the same thing as a plus b times a minus b. So if sometimes we can take that and turn it into that. Sometimes we can take that and turn it into that. And the benefit here is that this side kind of works with the Pythagorean identities that we work with quite well. So let's show you what I mean. So if I'm trying to make that, when I know how we multiply fractions together, I'm going to want to turn this denominator into a single term. It's always easier as a single term. So I'm going to multiply it by its partner, which is going to be 1 minus the sine of theta. Now, because I'm multiplying by that on the bottom, I must do the same thing on the top in order to not change the value of it. So what I get overall here is I'm going to get 1 minus the sine of theta squared divided by 1 plus the sine of theta times 1 minus the sine of theta, which is 1 minus the sine squared of theta. So it's not the same thing on top and bottom. Now if I convert this side, secant is the same thing as 1 over the cosine of theta. Tangent is the same thing as the sine of theta over the cosine of theta. And maybe you can see where this can go very quickly by this method. Now, on the left side, 1 minus sine squared, if we think about this, think about your Pythagorean identity. Cosine squared plus sine squared is 1. So 1 minus sine squared is the same thing as cosine squared. So I'm going to get 1 minus the sine of theta squared divided by the cosine squared of theta. Now, on the other side, these two fractions I can put together because they have the same denominator. I'm going to get on the top 1 minus the sine of theta over the cosine of theta. And then that whole thing's being squared. So the benefit here is that this is a pretty simple site. When we simplify the right side, when you square a fraction, you square the top and bottom. So this is the same thing as 1 minus the sine of theta squared over the cosine squared of theta, which is the same thing that we have over here. So we've effectively proved that they're the same. So if you think to do something differently right off the bat, you can still get this done. It may just take more work and it may not be as clear as what to do. So try and think about, what pieces do I have? How can I simplify them to make them work best together? There's no wrong way to go about proving identities other than to use incorrect mathematical practice. So like if you square things incorrectly, or if you don't add fractions correctly, or if you replace things incorrectly, those are the only things that can really mess you up. Certain methods will take longer than others, but the more you do this and the more you practice, the more you'll see kind of obvious ways to go about solving these problems.